I work for a company called Loop. I'm the CTO there. We basically are a customer service automation platform. We automate anything and everything around customer service. We work with some large e-commerce platforms, some large banks in India. So one of the things that we are very good with is chat automation, right? We started with chat automation and we did really well with it. With LLM, even before LLM, we did a lot of machine learning models of our own, and we kind of automated a lot of these chats, text-based customer service from our side, right? It's now moving into the direction where voice is the biggest pie, and we are trying to automate voice, and the challenges around voice is what I'm gonna kind of go into details here. So what happens with the current voice implementation is basically everything is IVR based, right? Everything is, you just start with the conversation. When you call customer service, say Airtel or a bank, the first thing you do is press 1 to go here, press 2 to go here, press 3 to go here, and then you wait for a long time, and then somebody at the other end, if he's free, they'll come and answer your question. Otherwise, you're basically trying to play around with the menu, and that is the problem that is there, right? And most of the companies who come to us to get this issue solved are also concerned. It's not that they don't want to solve this problem, right? They are also concerned that our customers are giving really bad CSAT because they are just playing around with the menu and they are not landing on the problem, solving the problem. We're not able to solve the problem, but they don't have enough manpower, right? The call center business is a really hard business to run. If you see the call center business, the churn rate is somewhere around 10 to 12%, right? The biggest concern they have is if there are 100 people who are solving the customer calls now, there are 10 people who are going to leave at the month end, and I have to train those 10 people. Now imagine you're basically in 10, 12 months, your whole customer service staff is going to turn over, right? Now you'll have to train them all over again, and that cycle continues. So the biggest problem that they have is knowledge and basically getting those things done. And that is why you will see these kind of issues with where you say, hey, press 1 for sales, press 2 for customer support, etc., and keep going there, right? And that's the huge problem, right? The people started moving into voice assistants, and these voice assistants are mostly FAQ based, right? These are, if there is a keyword match, you will be taken somewhere. And that's the routing. That's the best they could do, saying, hey, my internet is down, and they can catch internet is down, and then they'll give you a option to where a recorded message starts playing, saying that, hey, go restart the modem. Do you see a red light there? Do you see a green light there? And it's not even responsive, right? If you go and say, hey, all the lights are green, I still don't have a problem, I still see a problem, there is nothing because it's a recorded message. There's nobody who is gonna listen to that statement and come back and answer. And that's where LLMs kind of make a little bit of a difference, right? We'll come to that, but there are challenges with that as well. Yeah, that's basically automated call routing that happens, and then voice bots come in. Voice bots are basically FAQ based, basically recorded message, and they're just playing the recorded message. And that's the existing landscape. But what is happening is the box here, right? The box here, which is basically the LLM block. And people are basically trying to say, can I bring in NLP LLM block, and that will solve all my dialog flow, all my dialog manager problem. And dialog manager is basically, I'm just representing dialog manager as a backend for your customer service, which will go and talk to your backend, go talk to TTS layer, etc., and do the systems integration at the backend. So this is basically what is coming in to the system. That also brings in a lot of challenges in with it, right? it's already a complex system. If you look at the top to bottom, it's already a complex system. There is customer who calls in. There is a telephony line which is sitting there. It has to figure out the exchange. It has to land the call in the correct place. And then there is SIP integration. There is DID integration, etc., etc. And then IVR comes in. And then there is STT that happens. And then the LLM comes in. So everything that happens, already there is a bit of a latency that gets added, right? And that is the biggest challenge that we see, which is latency. Every time you see a LLM bot playing, I'm not sure, you would have heard a lot of these demos that Google does or Azure does, and you would see that there is a amazing demo that happens, right? They basically are showing a customer speaking, and immediately within few milliseconds somebody else responds, and that continues to happen. And the minute you try it out, it's a different experience, right? You say hi, and you wait for 2 seconds, nothing happens, and then somebody comes and says, hello, how are you doing? And then you say, hey, I am looking for something, and another 2 seconds, and then somebody else comes and gives, hey, can I get a glass of water, please? Sorry about that. Then there is some other bot comes in and says, gives you a response for that, right? So that keeps happening. Thanks so much. That keeps happening, and you would wonder what happened from the demo till the actual implementation. And that's what the biggest concerns that we face, right? When we started digging deeper into voice implementation for our customers, the biggest issues that we faced were latency, accuracy, and user experience, and in that order. Basically, the latency comes because, so let me just touch upon the accuracy first, and then I'll go to latency. But the accuracy is the biggest concern because there is layers that are happening before your customer query is answered, right? The biggest one is speech to text, and speech to text right now, the best speech to text that exists will give you 85 to 95% accuracy, and that too at a pristine environment, right? Environment where you basically have no noise, no background noise, nothing happening, and still you speak in English, and almost all these libraries are written with English in mind, no Indian languages in mind, right? Even if you're speaking in English, it takes 85 to 95% accuracy. It's not beyond that. A lot of sentences go really, get translated really weirdly, and then that throws off the whole FAQ engine. And if you go back to that FAQ engine analogy, the minute STT does a mistake, your whole pipeline goes for a toss, because STT is not identifying the keyword that customer is saying, and your underlying keyword identification goes for a toss, and then there is no answer that is there, and everything kind of stops working there, right? So that accuracy of 85-95% it already goes down in the real world. It's not 85-95%. I mean, I can give you an example of I would have loved to play that here, but one of our customer who were ride-sharing customer, one of their rider or the driver calls and says he's sleepy and he needs an ambulance, right? And that's happening in a Hindi. And if you actually just send that bit of audio to an automated layer, it is going to identify that there is something wrong and needs to book a some medical emergency, etc., etc. But if you keep listening to that conversation, at the end of the call, driver is saying, hey, I'm bored because I'm not getting any rides, right? So and it was in a Hindi which was more of a fairly Bihari accent, And it's very hard for any STT to catch it, right? And now if you are building a voice automation for that, that's going to be really, really challenging. So in the real world, that accuracy goes down. And there is speaker variability, there is background noise, and again, coming back to the same customer example who is ride sharing, the drivers who are calling their customer care are standing in the road with a lot of noise in the background, right? Figuring out what to do, what conversation needs to pick up and what doesn't need to be picked up is a big, big, big challenge, right? This is one of the major challenge that we kind of started looking at post latency. The way we started looking at it is we won't be able to solve for accuracy in all the places. At least let's start with the low hanging, which is background noise, right? We built our own WAD layer. So there is already enough WAD libraries available in GitHub if you go. And there is one called Celero. Celero does amazing job as it is just out of the box, right? We picked that, we started building our own layer on top of it, changed the weights a little bit, and then started testing. It really worked well with, again, English, right? And it's, I mean, WAD doesn't matter whether it is English or Hindi, but it really did well with English because most of our conversations with English were a little longer conversation, and WAD doesn't work with smaller conversation. If you listen to Indian conversation, when a customer calls, it's usually ha, na, yes, no, whereas in the West it is a little longer sentence, right? The small talk itself is a little longer. So it worked really well with Western call centers, but it really didn't work well with Indian call centers. So we again have to go back to drawing board. We figured out that there is energy thresholds that we can play around with in WAD libraries. And those actually kind of gave us good results. Those started giving us quite a bit of good results. So we started playing around with those libraries settings a little bit, and those started giving us a lot good results. We still have speech to text around 80 to 95%. 95% in really, really good scenarios. We still aren't really great at speech to text in a lot of cases. But what we did was we added, after the speech to text, we added a layer of LLM. It does add a little bit of cost for us, but it does increase the accuracy part of it. Basic LLM, which is like a 2 billion model, if you give it, as long as it understands Indian languages well, if you give it the sentence and say, hey, this is the context of the conversation, and this is what the input that I have gotten, is this what is correctly translated or transcribed or not, it does come back with a little better query from the user. We started taking that query. As I said, it increased the cost a little bit, but it gave us a hell lot of better accuracy. So 2 things that helped in this case was, one, STT layer, we basically used off the shelf from the cloud, but we added a post-processing. That actually helped quite a bit. And then WAD library, right? That actually did a lot of magic, because as soon as WAD library came in, our accuracy went up a little bit because we were able to clean up the background noise. We were able to figure out what is the energy level at which the speaker is speaking. When I am talking on this mic, there is certain energy level that I speak with, right? And we were able to identify that energy level, tune it to that, and then so initial 2 seconds of customer conversation, we identify what that energy level would be, and then we kind of tune it over the time of the call, we kind of tune it. And that gave us a lot better results with accuracy of the conversation. Moving on to latency, and I basically started writing quite a bit, and then I said, okay, I mean, last 2 months or 3 months have been just spending a lot of time on latency for me. So if you ask me, I can write like a book on this, and that is why the ... that you will see, right? It is just when you are working with voice, basic voice, no LLM involved, there is inherent latencies that are there, right? As I mentioned, there is a layers that happens. There is an exchange. When you call from a mobile number to a mobile number, it's just a couple of service providers who are interconnecting your call, and that call just goes through. But the minute you have a corporate sub call center that is picking up your call, there is a lot of things that keep happening in middle. There is STT that happens, and then there is again the dialog manager that comes in. Before the dialog manager, there is quite a bit of SIP gymnastic that happens. A SIP is a server where your call interlinkages happens. So there is quite a bit of gymnastic that happens at that layer, and because of each layer, so even a best STT right now is going to be giving you a 50 to 100 millisecond delays, right? And then there is buffering involved. So the way a basic STT would work is, if I start talking, it'll wait for your sentence to finish, and then few more milliseconds to make sure you finish the sentence. Because it doesn't want to kind of create two buffers and then do all that stuff, right? There are some which do this better with words, and then stream those words, but then there is a lot of heavy lifting that has to happen, and a lot of these telephony PBXs that are set up at a corporate are not set up for that. They are not set up for buffering and all streaming, etc. And you still have a lot of those e-commerce platforms who use ancient place where you have to wait for the customer to speak the whole sentence, wait for that few milliseconds, and then the whole sentence comes through, right? That is the STT layer. And then the TTS layer, again, the same thing. TTS layer is even more challenging, right? Once the conversation happens and then you have an answer from LLM, the challenge is LLM can stream, and that streaming has started happening now. It's not even very, very old tech. It's like few months old that streaming from LLM has started. But LLM streaming is word by word. It's character by character. It's not even word by word. It's character by character. Now you are literally writing a parser which kind of gets the output that you are looking for. And imagine if you are automating stuff, right? Let's say an example. You want to ask your LLM saying, hey, customer is asking for a refund, right? And there is a process documentation that is sitting there in the RAG somewhere that you need to pick up and give that information to the customer. Now that will be in such a certain format, right? It'll have bullets, it'll have some punctuation, some which are bold, some etc., right? So all those need to be now translated to emotion at the end of the day. Also, you also need to kind of make sure you have correct sentence ending, right? You have a refund resolution being, hey, for electronics, you have to wait for 24 hours or follow these steps to get the refund, etc. Now you have to wait for the whole sentence to finish before you can even start buffering and sending. So streaming itself, a character by character or a word by word streaming does not work really well. You still have to buffer on your side to make sure that happens, that whole sentence comes through, at least the first sentence comes through, and then you send that. Now to get even a first sentence, you are waiting for at least a second or half a second. So you're basically adding latency, as every layer here is a latency. And I'm not going to say we have solved it to an extent that it's seamless and we are able to go to the Google level. But what we have done is we basically moved away from, just to give you guys a very high level view of how LLM implementation call center works is, there's going to be some model that is going to be deployed, be it OpenAI, be it a Llama-based model that they have homegrown or whatever it is. They would have a RAG setup, which is basically a knowledge base, which will be mostly containing some 100 to 500 documents. We haven't seen anybody who has more than 500 documents per se. 100 to 500 documents which are indexed in a vector database. And then the query goes to this LLM. Query also goes to this vector database and tries to get the context from there, tries to get an answer from there. For example, just let's say you are doing a refund query. You basically go to LLM and say, hey, there is an instruction set that you follow. Here are the instruction set for the e-commerce platform. But if a refund question comes, you go to RAG, go to a knowledge base that you have, a vector database that you have, try to see if there is an answer there, right? And if you have answer there, get that answer and then reformat or rephrase that answer and then send it to the customer, right? That's usually the flow with the LLM, right? On a high level, that's usually how the customer service support models usually work, right? There are some variation here and there people do, but this is exactly mostly the deployment architecture for most of them. Now, with that in place, streaming is given for a lot of these LLMs now. For example, Llama now started doing streaming in last couple of months probably. OpenAI just started doing streaming for a few months. So streaming is given for a lot of these. I mean, there are some open source LLMs which still don't do the streaming. What we started doing is we started doing streaming on our side with the each word, exactly what I was talking about, not waiting for the whole sentence to finish. With each word, we started buffering and started building TTS buffers, right? And those TTS buffers were what we started throwing into the actual end TTS. So basically, every one of these customer service support platforms use either cloud-based TTS or very less in-house TTS, right? So what we did was we replicated the TTS layer in our local, but we did not do text to speech. Rather, we did not produce like a voice files, wave files. We started producing a binary files which could basically be translated to wave files using FFmpeg, and those were done word by word, and we could figure out some syntaxes where we said do it at the when there is a comma that comes in, or a question mark that comes in, or there is logical sentence ending, right? And then when we actually started building our RAG database as well, we made sure that the sentences are not too long for all the answers. So we started with that. That actually kind of helps a lot. So when you actually build your RAG database, your knowledge-based database, just make sure your knowledge-based database is not very like a Ramayana book, right? You don't have like a long phrases of a story that you are giving to customer, because you need to be sharp enough. We started giving that. And then with LLM we did, so the model that we use, we basically tuned it to make sure that we don't give sentences which are more than like 10 words or 12 words. And there are places where it goes out and latency comes in for sure, in those kind of use cases. But other than that, we started doing those small tweaks, and our latencies came down. And as I said, I mean, we are not, I would not stand here and say we are in milliseconds. We still take like a second and a half to respond back, but our response times are second and a half, right? It's that's the response time that we basically are working with. The last one, which is huge, and we are trying to solve this, and we have some workarounds for this, but it's not something that is very, very well done, and it's not well done in traditional call centers as well, right? Is user experience in voice call centers is voice call is very, very hard, right? You call a customer care, and let's say a bot starts speaking to you. You don't want that bot to end up like, the other day, I was reading on Twitter, somebody was complaining that Geo, as soon as you start running out of your balance, before like 3 days, it starts giving you, when you make a call, it starts giving you like a gyan of, hey, you have not recharged and you have this offer, that offer. Now, you don't want that to happen when you call the customer care as well, right? It shouldn't start playing. And example is Airtel. You just call that. The first thing it says is your bill is due or you have paid the bill. I already know that. You don't really need to tell me that again and again when I call your customer care, right? But that happens a lot. Now, in this conversation, I'm not interested in that. So I would want to barge it. I would want to kind of just say, hey, I'm done. I want to move ahead. Can I do that? And that's barging. We do that in a very crude way right now, wherein we identify using WAD that we have. We identify if a customer is speaking while the bot is speaking. We identify that, and then we basically stop our bot buffer, but it's error prone because you would have sent a certain amount of buffer to the TTS already, and it would have already spoken that, and it will continue to speak that whole sentence, and it'll stop at the sentence end, right? It will not tell the whole story. Thanks. Hello? Yeah, it will not tell the whole story, but it will at least stop at the sentence. So that's bargain. But it's a hard problem to solve, right? The other one I would want to talk about is when you are doing voice customer support, it's very hard to handle latency. Latency is going to come, right? I mean, you can do quite a few things, but latency is still going to come because you are, when you are talking to a human agent, they want to check a CRM system or their OMS system. They still want to go there and check and come back. They will put your call on hold, right? There is some user experience there. When a LLM is doing that, it's a really hard thing to do. In a chat, it's very easily solved. When you speak, when you say something, there are 3 dots that come in, and it will show that somebody is typing. That somebody is typing is a hard problem to say in a voice call, and it's what we do is we use filler words, we use filler sentences saying, hey, we are going to come back with an answer, but that sometimes doesn't work really well because it's probably not that. It's probably that, hey, we can't solve you, because it ends up in a call. It ends up happening that we're going to solve your problem. We'll come back with a solution to your problem, and the next sentence is we can't solve your problem, and it just doesn't go well. But it happens quite a bit of time. So, but that is one of the way we solve that problem, and it's not very elegant. So user experience in voice is really hard problem. We have tried solving quite a few of them, but yeah, I mean, it's not something that we can 100% solve, but we have tried solving in certain use cases. I did have a demo, but yeah, I mean, we can't play the audio, but in the real world, it still is a problem, right? Because the way it would work, even with Google, right? Google's own call center stack that they have, if you put the same use case that we are solving with that, when a bot is speaking, it would say, hey, your refund will be processed on XYZ date, period. You will get your refund within 7 days, etc., right? Now, the first sentence of your refund will be processed within XYZ date will already be sent to TTS. It would already be buffered, and it will be ready to go. And when that happens, when a customer speaks, right, at that time, it wouldn't stop. It usually continues to speak. It's very hard to clear the buffer at that time. You have to do hard reset of the buffer, but if you do that, then you are basically also running into a lot of context issues. So in demos, it really works. I mean, we can demo that as well. In the real use case, it will always have a problems with margins. Thanks. Sure.
Hey Ravi, my name is Chakravarti. Thank you for the very insightful presentation on this. So my question is, I'm actually building a data privacy product for LLM based on ensuring zero data leaks. So my question to you is, partnering or being your customers, how do they see privacy as a concern when you particularly deploying LLMs? And have you considered solutions in place, and what do you actually work today with?
When we work with LLM, that's usually the question a lot of people ask, right? And we ended up doing quite a bit back and forth on that. We ended up solving it internally because frankly, solving a customer service business for any other enterprises without having that layer of LLM or GenAI figured out for us was a clear no-no. So we ended up figuring out that ours. I mean, if you just, funnily enough, just before coming to this, I just posted in LinkedIn a big thing on how we handle privacy, how we handle training, etc. What we ended up doing is quite a few of tricks wherein we deployed slices of, if a customer needs a specific tuned model, we ended up deploying a tuned model for them specifically, and then that cost kind of then turns over to the customer, etc., etc. Our base model training usually happened with a lot of synthetically generated data, not customer data. And we have our own metrics. We have our own blue scores that we are defined. And these blue scores actually kind of say that, hey, there is a bit of hallucination that is stepped in, or there is a prompt leakage that is happening or not. The RAG is, the context is correctly coming or not, and that is carrying good over into the chats correctly or not. All that is being kind of monitored as a metrics on our side, and that's how we ended up solving it. But we are still in the journey, right? I mean, there is quite a few things that we still keep learning on the data privacy on LLM side. The basic stance that we took is we're never going to use customer data to train. We're never going to use customer data to, if there is privacy data, we're never going to unencrypt and do this, right? We will just use the encrypted data, and then if the training has to happen, we'll do it on the encrypted data, and basically the weights will get transferred over. So we did localized training in which the training happened localized, and then the weights of the model just transferred over to the base model of ours. So those kind of neat tricks is what we did. We're still learning, but the stance that we took was we have to solve this internally. We can't go out because this is our bread and butter.
Okay, thank you. Just as a follow-up, so LLM being just one part of the case, but let's say in a bot, typically, right, somebody could actually be revealing their credit card numbers, for example. Hey, I lost this number, can you block the card, let's say. And that may not go to an LLM, but it's sitting somewhere in the cloud. Maybe even if it's encrypted, it's still on a breach. You still are exposed to something that's very revealing about your customer to a third party. So is that a concern, or is that because there is encryption and therefore there is no need at all?
Those customer numbers per se are not even encrypted. I mean, they are basically masked. We end up masking them because there are elements that customers come and say in our platform. There are elements or entities that customers come and say, hey, these are fields that we don't want you to track, keep in your database, etc., etc. We simply mask them, and if we have to show it on agent dashboard or on the company's internal folks, that will be fetched from the internal system of the customer, and it will always be on the transit. It will never be at the rest in our system. So it's usually at a cache layer, and cache gets destroyed. So we don't store the data at any point of time. It's always masked on our side.
Okay. Thank you.
So the processing part, if you see, getting the speech and then speech to text, text to LLM, LLM to back to speech is a very complex process, and putting a constraint of real time is still more complex in terms of the servers and other thing. So how do you compare the cost of this versus a human call center, basically, feasibility point of view? Yeah,
in India, that's a big challenge. That's a right thing to stress upon as well. In India, that's a challenge, right? I mean, in India, customer call, if you have to solve using LLM, ballpark, you will end up spending 2 rupees to 4 rupees, worst case 6 rupees. If you are really sophisticated using 4.0 and 4 and all that stuff, you end up spending 8 rupees. If you put a human, that's 2.5 rupees at best. So in India, it's I mean, voice LLMs coming to India, that's a big hurdle, right? We solve for Western countries, we solve, there the call per solution, for example, one of our customer who is a large broadband provider in UK and US, they basically spend close to $125 if a customer complains that their broadband doesn't work. That's nothing if we can solve it in 10 rupees, right? For them, it's a really win-win situation, for sure. But yeah, I agree with Indian customers, it's usually a challenge. Some customers are going on LLM because of quality reasons, right? Example, the one that I just mentioned, the riders calling for their insurance, riders calling for their problems that, hey, I'm not able to get a ride, I'm not able to do this XYZ. Those kind of challenges, those need a little more higher quality, because you are now losing those drivers because you are not able to answer those queries correctly and in time, right? There they are ready to spend a little more and make sure the quality is good. And there we can make inroads, but if there is a price sensitivity, it's agent who usually wins in India. Yes and no. So the typical call lifecycle is you get a call, your bot tries to answer the questions. It's basically FAQ workflow based. It cannot solve the problem, sends it to agent, sends it to LLM. That tries to solve the problem. And then your call ends. And then there is something called as ACW that happens. So that's called after call work. So in the after call work, the metrics that you are saying, they get captured most of the time. But we have our own argument, but usually it is back and forth, right? We go and say, hey, give us that ACW, we'll run through your calls and we'll definitely be able to give you back that 50% of your ACWs are wrong. They were tagged wrong. Customer issue was not resolved. And we did that with one of our customers who's into selling motor vehicles, right? There we took their leads calls, basically the marketing leads call that come through, and we ran them through after the end of the call, we ran them through and compared the ACW, and 70% of the leads were getting leaked, right? 60-70% of the leads were getting leaked. They were not getting marked as leads. Yeah, so they were not getting marked as leads by agents, but when we did that, we kind of said that, hey, you're losing 70% of the leads, of which if you convert 30%, which is industry standard, you still end up getting a good amount of conversions. That actually kind of triggered conversations. That can happen in marketing. Customer service is a very, very hard business to be in when you're, I mean, it's a cost center, so they usually are cutting costs.
Hi Ravi, great presentation. I just want to know what is the use case of CDP, Customer Data Platform, right? It is mostly used by the marketing guys, right? They collect the data and build the persona of the customer, right? And utilizing that persona, they can train the model as well. And yeah. What do you think? How that affect and the customer support, Ravi?
See, CDP is important part, but usually we don't get involved into CDP business. We always keep that at a customer side rather than we keeping it, because as I mentioned, privacy being a concern, if we end up building CDP, then it will become our problem, but we never go there, or we would rather not go there now, because it is not something that is a core business for us, right? Customers' data, if you are capturing, you need to be a little more vigilant on all the classified data that is coming through, all the private data that is coming through, etc., etc. And we have our own mechanism of handling it in a customer service platform of ours. So we would rather keep CDP at a customer end. CDP feeds us a lot of data. We have a lot of integration with CDPs. I mean, It's Salesforce, if you call it as a CDP, right? But we have Salesforce, we have HubSpot, we have other CDP platform integrations with us, Moa Engage, Web Engage, etc., etc. We do that integrations. We get the data for the customer, process it, and then send back. But it's always in the transit. We don't usually store it.
Ravi, that is for the personalization part, right?
Correct.
Yeah. All.